sorry, this 2 is also there, twice dt. This 2 here, this is twice dt, I'm sorry, this is twice dt. 2 into 8 is 16 a square. This is 2 dt here in place of d theta equal to twice dt. So this 2 into dt I have written. So this is 16 a square, 0 to pi by 2. Now this is cos 4t dt. What is value of cos 4t by reduction formula? Let me write here. Since sine of integration 0 to pi by 2 cos 4 theta d theta is equal to 3 by 4 first point, then 1.2 into pi by 2. If it is even power, then we convert like this: n minus 1 upon n into n minus 2, sorry, n minus 3 upon n minus 2. So this is n minus 2 means 2 here, and this is n minus 3 means 1. 4 minus 3 means 1. 1.2 into pi by 2. Finally, if it is 1.2, then we write pi by 2 also. That is the value here. So let me write here. This is 16a square as it is, and this value is 3 by 4 into 1.2 into pi upon 2. This is 4 to the 8 to the 16, 16 completely cancelled out, which is nothing but 3 into pi into a square. 3 into pi into a square. This is the area of a square unit, area of the surface bounded by this cycloid and x-axis. Between x-axis and cycloid, this is the area 3 pi a square. Therefore, the ratio, let me find out the ratio now. Therefore, the ratio of the two areas, ratio of the two areas. What is the area? Area of revolution and simple area. That is area of surface of revolution. The same area, but this area is revolved about. Okay, revolved about x-axis. That area is to area bounded between cycloid and x-axis. That is the point here. That means 64 pi a square upon 3, this first equation, and second is this, is to 3 pi a square. 3 multiplied there, pi square cancelled out. It is nothing but 64 is to 9. So 3 3 is 9. You can take 3 LCM. It is 9 upon 3, we can write here, no problem. So 9, 64 to 9, pi square cancel out, 3 cancel out. 64 is to 9. This is the answer we have to prove. 64 is to 9. We have to prove that the area of these two, ratio of these two areas is 64 by 9. 64 is to 9. Okay, 64 is to 9. So hence it is proved. Okay, these two areas we have to calculate, hence proved. Only this ratio we have to prove. Question number 9 we have completed. Okay, let me take question number 10, the last question. What does it say? Okay, now question number 10 is of what kind? Let me check. Question number 9 is of what kind? Let me now check it. Question number 10 now. 9th we have done, 10th question. Now question number 10. What does it say? It says find the area of the surface generated by the revolution of the lemniscate. So the lemniscate here, lemniscate is r square is equal to a square into cos 2 theta. This is first equation only. Okay, now about the initial line, it means this is a polar equation. So in polar equation, what is the formula that I've discussed in the beginning, but this question I've taken just to introduce for the next lecture series. Because in the next lecture series, I'll take polar equation, this area of surface of revolution for polar equation. This is one example of that, one question, one instance of that kind. So let me take this instance here. R square equal to a square cos 2 theta. Okay, what is this? How to trace this? This tracing we have done, but still let me trace it first. If I put r equal to 0, putting r equal to 0, so this is a square into cos 2 theta equal to 0. What does it give us? So cos 2 theta equal to 0. That means this is cos pi by 2 is 0. So this 2 theta is equal to pi by 2 plus minus pi by 2 here. You can take plus pi by 2 minus pi by 2 because cos pi by 2 or minus pi by 2 is 0. Okay, so that is therefore theta is equal to plus minus pi by 4. It means there is a loop here which is of multiple of this also, 3 pi by 4, okay, and minus 3 pi by 4 between. Next point will be 3 pi by 4 plus minus etc. This kind of, because this is only twice to multiply, there will be only 2 in this case. If it is even number, then only okay these two angles we have to take. So what kind of curve here? Let me draw that curve. This is the initial line. Let me take this is initial line of x-axis, initial line here. Okay, and this is perpendicular line at theta equal to pi by 2, and this is theta equal to 0 here. Initial line is this. What the curve here? So between pi by 4 and minus pi by 4, if I draw two lines here, if we take this is theta equal to pi by 4, and here it is negative, and here it is theta equal to minus pi by 4. The curve, the loop is here of this kind. Okay, these two loops are there. These two loops, take the bigger loop here, this loop and this loop. This is the shape of the lemniscate here. We have to find out this area. For the area here, so first of all, what is this point here? So we will take the limits theta equal to 0 to pi by 4. But if I revolve this lemniscate, this is one loop here, this is double, we will make twice of this. If I revolve, this is O point, let me take, and this is A point, let me take, and this is A dash here. So what is the, now if I revolve this, now this is, since this is polar equation, let me take, this is P point, this is P point, this is Q point here, this is delta theta, and this is theta here, angle theta to delta theta. Okay, so P r theta, we take the r theta here, r and theta, and this is r plus delta r and theta plus delta theta. Okay, this length of Q point here. Okay, we can take this. Now what is the area of this that we have to find? So area of surface of revolution. So this OPA is a revolve about x-axis, about initial line, or this initial line is this line. Okay, at theta equal to 0. So this initial line, if I revolve this, so this loop, this area and this area, the double of this area will be there. So this is here 3 pi by 4, and this is minus 3 pi by 4. Between these two angles and these two angles, there are two loops here. So area of the two loops we have to find out. Area of the rotation, revolution of this loop about the initial line. This will give us twice of that. What the area here? in case of polar equation. The same formula we have to apply to area, and we take total area. Area of the surface of revolution of the surface of revolution of the lemniscate about the initial line, okay, will be, let me change this, will be what it will be. It will be, here limits are 0 to, here theta is 0 at this point, 0 to this pi by 2. So theta is 0 to pi by 2, or we can take here theta is 0, at this point theta is 0, theta to pi by 2. Okay, sorry, pi by 4. So limits, this is twice into, let me find, 2 into total area. So this area of surface of revolution, this is the basic point I'm talking about. Area of surface of revolution of OPA. I'm sorry. This OPA, the loop, a part of the arc of the loop, OPA. The arc OPA of the loop, this loop first. So this is twice of this. Well, this area is also to be included. This loop, if it revolve about initial line, and this whole surface of this solid will be generated, that area we have to find out. So this twice of this, because this area is also there, twice of this area. But the formula for this is twice into, now area is again twice pi in case of this. This is pi into ds. Okay, limits are here 0 to pi by 4 in this case. So by here we will, by we have to substitute by, you know that in polar coordinates x equal to r cos theta, let x equal to r cos theta and y equal to r sin theta. This is in case of polar equations. Polar coordinates, we take x equal to r cos theta, y equal to r sin theta. So in place of y, we will put this r sin theta. What is ds upon d theta? We have to find out into d theta. So ds upon d theta, let me write here. What is this? Ds upon d theta is given by, so in case of polar equations, ds upon d theta is equal to square root r square plus, this is dr d theta whole square. That is the value of ds upon d theta. This we have to calculate here. Now this is now 4 pi. Let me write here this formula now. 4 pi in this case 0 to pi by 4. Here it is y. Okay, y is r sin theta. This is r into sin theta into ds upon d theta. Still I have to calculate into d theta. This is the value which we have to calculate or require. Okay, we have to calculate this. Still we have to estimate this. Now let me write here. What is the value of r square here? First dr d theta in this case. Okay, so dr d theta, if I write here, this is twice r. This is twice r into dr d theta is equal to this value. This is minus sine a square into sine 2 theta into 2. Why into 2? Because this is differentiation. Dr d theta twice r into dr d theta, r square is twice r. Dr d theta equal to cos 2 theta into 2. Sorry, cos 2 theta is differentiated minus sine 2 theta into 2. So this is twice a square. 2 to cancel out. What is dr d theta? Therefore, dr d theta, let me write here. Dr d theta is equal to minus sine, this is a square into sine 2 theta upon r. Okay, r divided by this r, a square minus a square sine 2 theta upon r. This is the value of dr d theta. Dr d theta we have to substitute here. This is r square. We substitute that value there. This is a square. R square is a square cos 2 theta. Now plus dr d theta means square of this. It will be now a4 sine square 2 theta. This is sine square 2 theta because the square of angle is same 2 theta. But sine square will be there divided by r square. Now r square is this again. So we substitute that value. It will give us under root a square into cos 2 theta. Let me write here as it is, plus this is a4 into sine square 2 theta divided by r square. R square from first equation is a square into cos 2 theta. So this a square and this a4 is a square. A square sine square 2 theta, and this cos 2 theta if I take here, it will be a square cos square 2 theta. Okay, so that will give us, let me write, a square if I take out, it will come out as a only. It will be now cos square 2 theta plus now sine square 2 theta. This is 1 upon cos 2 theta LCM. So finally the value is ds d theta, therefore is equal to a, this value a is out, and this is 1 here, a into square root of 1 divided by under root cos 2 theta. Try to understand. This is nothing but a upon under root cos 2 theta. This value of ds d theta. Now we have to substitute this value ds d theta as a upon under root cos 2 theta. And what is r sin theta? Let me substitute that value also. So therefore, area here, let me write here area. Therefore, area, this area of revolution, in this case area of solid of revolution, area of surface of revolution, okay, of the lemniscate. So therefore area is equal to 4 into pi, this value 0 to pi by 4 r sin theta. This is r is here, this will be r square is equal to a square cos 2 theta. Therefore r is a under root cos 2 theta. Try to understand, square root of a square cos 2 theta is a, or here it is r only, r sin theta. So r is there, r is a under root cos 2 theta from first equation into sin theta as it is, into ds d theta is, into ds d theta is a upon under root cos 2 theta. Try to understand, into d theta. So this under root cos 2 theta cancelled out. This is a square. It is 4 pi a square, 4 pi as it is, a into a square, sine of integration 0 to pi by 4. Alright, this is 0 to pi by 4 into sine theta into d theta. Got the point? This is the value. Now we have to integrate this further. Further integration of this, that will give us the final answer. Okay, so this question, I mean total area of this loop, or so okay, area of surface of revolution of these two loops of this lemniscate is this area. What is this? Is 4 pi a square 0 to pi by 4, and sin theta integration is minus cos theta 0 to pi by 4. It will give us 4 pi a square. Okay, now this is minus cos pi by 4 minus plus in between cos 0. Okay, it is nothing but 4 pi a square. This is 1 upon root 2 minus 1 upon root 2. This is plus 1 because cos 0 is plus 1, and cos pi by 4 means cos 45 degree is 1 upon root 2. It is nothing but 4 into pi a square. In bracket it is 1 minus 1 upon root 2. This is the answer finally. Area, this is, so it is square unit. Area, no need of writing square unit in this case, it is total answer. So answer of this question is 4 pi a square into 1 minus 1 upon root 2. finally this is the answer here. Clear? So this question is for polar equations. This question I've taken so that next, I mean the foundation for next lecture series can be built. Okay, it has been built here. We understood that what formula we apply for polar equations. Just we substitute the value of x cos theta, sorry, x equal to r cos theta, y equal to r sin theta. These are the polar coordinates we substitute. Okay, and our value of r is given there, and ds d theta we calculate as under root of r square plus dr upon d theta whole square. That is the value of ds d theta. We have to substitute that, convert that into polar coordinates. Okay, so this is the final question regarding. So parametric equations we started with this. Most of the questions are of parametric equation, and this one we have taken here for polar equation. Okay, this is what. Sorry, this lecture series ends now. In the next lecture series, we will talk about polar equations now, because this is the basic for that polar equation. Okay, so those questions I'll discuss in the next lecture series. See you up to that time. So see you in the next lecture series. Okay then, bye bye.